So in this video, we will be learning about binary search. So let's understand the problem first. So we are given an array of size n. In this example, it's 5. So we have the array as 1, 2, 3, 4, and 5. And we will have to find an element k from the array. That is 4 in this case. So the position of 4 here is 3. So the output is 3. Another example is that suppose if the element k, which we need to search in the array, is not there present in the array. So in that case, the output will be -1. So the problem is clear now. So let's first approach the naive solution. Before approaching any solution, we should first see the what should be the naive approach. Okay. So the naive approach will be that we iterate the entire array through a loop and we find the kth element. Sorry, if we find the number k in the array, what is the index of that element. So in that case, uh, that will be a little uh, costly, that approach, because it will take big of n time. So that's why binary search is there. So in this algorithm, the approach takes big of log n time. That's why it's more appropriate, more optimized solution. So now let's see what happens in the binary search. Okay, so in binary search, I will write the code side by side. So in binary search, what we do is that we take three values here. So what will first will be low. So low will be 0, the first index of the array. Then high. What will be high? It will be the last index of the array. So it will be n minus 1. And next is mid. Okay, mid we are not initializing it. We will initialize it inside a loop because every time mid will be changing. So let's understand the approach, how we do binary search. So in binary search, what we do is that we take every time we take the mid of the array. How we calculate the mid of the array? It's simple. It's mid equals to low plus high divided by 2. So mid will be in this position. So that is 0 plus 4 divided by 2, that is 2. So 3 will be the mid. Okay. So after that, what we will do, we will be checking this number with the k, and we will see if it is if k is greater than this number or less than this number or equal to this number. If it is equal, it's simple. We will simply return the index of this element, that is 2. And if not, then we will see if it is if k is greater than it. If k is greater than it, then the array is sorted. So it will be after this thing. So we will have to iterate through this part of the array. And if it is less than this number, if k is less than this number, then we will iterate in this part. Okay, let's write the code, then it will be more clear. So what we'll be doing, we will be running a while loop, and the condition will here will be low less than equals to high. Why low less than equals to high? Because every time the low should be less than high, and also it might happen that in some cases low and high comes in the same place. So in that case also we should be checking it with the element k. So that's why low less than equals to high is the condition. Now we will initialize mid. So mid, as I discussed, it will be low plus high divided by 2. Then comes the condition. So we will be checking if array of mid is equal to k or not. If it is, then we will return mid. Then else if k is greater than array of mid, then we will have to return, sorry, not return, we will have to change the low here. So low will become mid plus 1. So let's understand why low becomes mid plus 1. So as I said earlier, that if k is greater than mid, array of mid, then I will have to iterate through this part because this part does not make sense. All will be definitely lower than k. So this part I will have to iterate, this part of the array. So in that case, my low will have to be changed because high will be same to same. I will have to change the low. So low will be mid plus 1. So that's why low equals to mid plus 1. And then else part, when k is lesser than array of mid, so in that part I will iterate in the left part of the array. So in that case, low will be same, but high will change to mid minus 1, right? And this thing will continue until low becomes less than equals to high. And now, suppose if the loop ends, so it denotes that I have not found the element inside the array. So in that case, I will return minus 1, correct? Now let's make a dry run and see. So 1, 2, 3, 4, 5 is the array. Low becomes 0 and high becomes n minus 1. So high will be 4 in this case. Now low less than equals to high. Mid becomes low plus high by 2. That is mid is now 2. So array of 2, is it equal to k? No. Is k is greater than array of mid? Yes. So what I will do? I will make low as mid plus 1. High will be n minus 1 only. So now again mid equals to low plus high by 2. That is uh, that is 3 plus 4 by 2. That is again uh, 3. Okay. So 0, 1, 2, 3. So this will be the mid this time. And array of mid is equal to k, as I can see. Array of 3 is 4 and 4 is equal to k. So we will be returning mid, and that is the end of the loop. So let's compile and run. So we have passed the sample test case. Let's submit the code, and here we have passed all the test cases. So yeah, so as we can see, using binary search, the complexity becomes a little more optimized. The solution becomes little bit more optimized. That's why binary search is preferred for searching. As I mentioned earlier, here also the expected time complexity is written here, order of big O of log n. So that is it for today, guys. In the next video, we will be discussing about more applications of binary search. Thank you.